Hey guys, Mr. McKinney here, just going through some more problems with limits, and those involving infinity, because sometimes things get a little bit wonky when we talk about infinity. So first of all, let's review the properties of limits. Basically, you're allowed to add limits, subtract limits, multiply limits, and divide limits. Now, it's pretty straightforward if the limits are both real numbers. It starts to get a little bit more interesting if one of the limits is either positive or negative infinity. So let's take a look. So let's assume that we've got the function f of x, and if we look at the limit as x approaches c, it's going to be positive infinity. And then we've got g of x, and then we look at the limit as x approaches the same value of c. This is some value m. We don't know anything about m except that it is a real number, so it's not infinite. So one of the limits is infinite, the other one is a finite value, a real number. So if I take a finite value and I divide it by infinity, when we're talking about limits, the answer would be 0. So a number divided by infinity, when we talk about limits, is going to evaluate to be 0. Now don't write that a number divided by infinity is equal to 0 because that's kind of meaningless, but the limit would be equal to 0. Now, if we have infinity and we're adding or subtracting a number, that number doesn't matter compared to infinity. So it doesn't matter how big that number is, unless it's infinite, infinity is infinitely bigger than it. So you can ignore it. Infinity plus a number is still infinity. Infinity minus a number is still infinity. Now, what if we were multiplying infinity times something? Now it just depends on whether we're multiplying infinity times a positive or negative number. So infinity times a positive number is positive infinity, and infinity times a negative number is negative infinity. Now, that may sound pretty straightforward, but let's look at some examples where it starts to get a little bit tricky. So in this first one, we've got the function f of x is equal to e to the negative x divided by x. We want to know what is the limit as the x approaches infinity of f of x. The limit of f of x as x approaches 0 from the left, and the limit of f of x as x approaches 0 from the right. Now, when we have functions that are combined like this, I like to think about them individually. So we can think about y equals e to the negative x. That would be the e to the exponential function, but then we have reflected it horizontally. So it looks something like this. You'd have a horizontal asymptote at 0, you'd have a y-intercept at 1, and then the end behavior on this side is approaching positive infinity. And then let's look at y equals x. That's the linear function. All right, so if we look at the limit as x approaches infinity, we're going to take the limit as x approaches infinity for the right one. So we can think about the limit as x approaches infinity of f of x as the limit as x approaches infinity of e to the negative x divided by the limit as x approaches infinity of x. And if I just look at my graph or think about it, as x becomes infinitely large, e to the negative x becomes infinitely small, or 0. This is approaching our horizontal asymptote of 0. So you've got a 0 on the top. If we think about what's happening to x as we approach infinity, we're going to infinity. Now again, I don't want to say 0 divided by infinity is equal to 0, because this is kind of meaningless. But I can say that this whole limit will be 0. A number divided by infinity is 0, whether that number is 0 or not. Any number, if you chop it up into infinitely many pieces, gets chopped down to nothing. So the first answer would be 0. Now let's take a look at as we approach 0 from the left and as we approach 0 from the right. Now, if I look at the graph of e to the negative x, I'm going to be approaching 1 from the left and the right. And as I look at y equals x, I'm going to be approaching 0 from the left and the right. Now the reason this one gets interesting is because I'm dividing by x. So if I'm dividing by 0, I'm going to be having some issues. So let's think about how we could approach this problem. We could say, so we can approach it the same way that we did the last problem and try to divide the limits. So look at that. Let's look at that first and then think about another way that we could do this problem. So if we think about the limit as x approaches 0 from the left of e to the negative x, and we divide that by the limit as x approaches 0 from the left of x. So the top would be 1, and the bottom would be 0. Now, we can't divide by 0, so this is telling me that I need to be thinking about infinity in some fashion. Now, as I approach x, like as I look at the graph of y equals x, and I approach from the left side as I approach 0, I'm going to be approaching 0, but I'm going to be at a negative number. So this is going to be approaching 0, but from the negative number, or sorry, from the negative side. So it's going to be a really, really small negative number. And if I have a positive number divided by a really small negative number, this is going to end up being negative infinity. Now, another way to think about this problem is to move the e to the negative x down to the bottom. And we can think about f of x equals 1 over e to the x times x. And you could break that down as 1 over e to the x times 1 over x. And then you could think about, as we approach 0, 0 plugged in here is no problem. So then you're really just thinking about 1 over x. So let's think about that graph real quick. The graph of 1 over x would look like this. And approaching from the left side, we're approaching negative infinity. Now, the same idea over here, except we're going to be approaching from the right side. So you could think about it like this again, except these would be pluses. You'd still be doing 1 divided by 0, or a number approaching 0, but it would be a positive number. So this one's going to end up being positive infinity. And again, you could break it down like this. 1 over e to the 0 is going to be 1, and then we just need to think about the graph of 1 over x. Now, as you're working through your homework, you always want to be checking yourselves. So I would graph this in Desmos and then take a look at it and make sure that what I wrote made sense. So we said that this was 0, this was negative infinity, and this was positive infinity. So, yep, as I'm going to the right, I'm approaching 0. As I approach 0 from the left side, I am approaching negative infinity. And as I approach 0 from the right side, I'm approaching positive infinity. All right. Let's take a look at another example. So the limit as x approaches 4 of 2x over 1 over x minus 4. Now, this one's a little bit tricky, and we can think about breaking it up as the limit as x approaches 4 of 2x, no problems there, divided by the limit as x approaches 4 of 1 over x minus 4. Here's where the issue is going to be, because I'm going to be dividing by 0 here. Now, 2 times 4 is 8, so we've got a whole number on the top. Now, when I do 1 divided by 0, that's telling me that we've got an asymptote, and it's either going to be positive or negative infinity. Now, some of you are going to think, oh, well, this is a rational function. We move 4 units to the right. The left and right side limits are not the same. So this limit does not exist. Therefore, the whole thing must not exist. But that's where we got to be a little bit careful. Because on the top, we're going to have a number. And on the bottom, we're going to either have positive or negative infinity. Now, whether I do a number divided by positive infinity or a number divided by negative infinity, and when we talk about limits, those are both going to be 0. It's either going to be an infinitely small positive number or an infinitely small negative number, but those both evaluate to be 0. So this limit is actually 0. Now, the easier way to think about this is if you divide by a fraction, that's the same as multiplying by the reciprocal. So we could also think about this problem as the limit as x approaches 4 of 2x times x minus 4 over 1. And then I can just plug in 4. 8 times 0 is 0. So that's another way to do it. And again, we should always be checking. So let's graph it in Desmos. And yep, makes sense. We got our point right there at 4, 0. All right, here's a chance for you guys to practice on your own. So if you want to, go ahead and hit pause. Try to work out this problem. Maybe graph it in Desmos and see how you did. All right, let's take a look. So 1 over x minus 4 squared as we approach 4, that's the squared rational. So we'd be over at 4, we'd have both arrows going up. So that limit is positive infinity. 2 minus 4 ends up being negative 2. We do a positive infinity times a negative number, we get negative infinity. And if I graph it, I can verify my limit over here. Both sides are going to negative infinity, so it checks out. I hope this was helpful. Have a great day.